this meeting is here to define a project for you, so that you can identify what you want to do for the rest of the semester in your project. And I would like to hear if there's already someone who has already an idea. I know that Rhonda has selected her project to be the Raspberry Pi cluster. We have added her to a Slack in which 2 students are already actively working every week on this particular project. And they're already developing code. And Rhonda should at one point catch up with them so that she knows what they're doing. At this time, they are trying to figure out how to burn the SD cards and put the Wi-Fi configuration onto the SD cards so that you don't have to punch in anything into the operating system, but can just take the SD card, plug it into the Raspberry Pi, and power up the machine without doing any modification. Rhonda, you may be doing it differently, so you can report to us how you do it, but please start interacting with the students on the Slack channel. Rhonda, yep. you are on the Slack channel, right? Yep, I'm on Slack, and I've got the documentation, and I did burn one SD card and put it in a Pi, and it works. I'll keep up with what they're doing, but. Yeah, good. So so today you saw some discussions. So I gave some tips. So they're still not entirely sure why the one student can't put these things on the Wi-Fi, despite the fact that I think they have done everything correctly, but there may be something else that we are missing. Okay. So one of the things that I would like you to encourage, Rhonda, is also try to figure out if you can put this thing on the Wi-Fi. Okay. 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 Anybody else has an idea about the projects that they want to do?
Professor, this is Praful, and actually we have been discussing about the automated AI service generator.
That's correct.
That is something that I wanted to understand more, but that is something that I would be interested in pursuing.
Yeah, so we already recorded videos on this, and I'm happy to redo this. Did you see the videos on this already or not?
No, I was planning to do that later.
So now I would like to have everybody who thinks they want to do the AI project click the green yes on, so that I can see how many people we are dealing with, because we probably have to break this up in case there are too many. Okay, no one. Yeah, Jonathan.
Hi, Professor.
Yeah.
Yeah, this is Xin. I have a question because I don't have much experience about this developing thing. So I only know some Python, so I have no idea of what kind of project I could really handle. So can you?
Yeah, that's something that is difficult for me to say too. So that's the reason why we go through these things. I think the easiest project we have is add volume management to things such as Google, Azure, and other providers. Second easiest would be likely the Google Cloud Mesh provider, the Google Compute provider, but that's a little bit more involved because you have to understand some security there and security groups and so forth. But again, you have from now till the end of the semester time to learn this. Okay. And there's a significant amount of time that you need to be spending on this. This is not a project that you can do in 3 hours or six hours or even 2 weeks. This is a project that takes the entire semester.
Okay.
And if you need to have additional Python knowledge, then you will be responsible for putting additional time into learning Python.
Okay, so can I do the volume management project?
Yeah, you will be declaring that somehow over the next week. I will put the spreadsheet up, and then you can put yourself in. And we talk once more about the AI project. And next week or the week afterwards, you guys will be learning about what's called Open API. And the Open API is in our cloud computing book, in this one here. And when you go there, as you know, we are now data center. We have passed architecture, and there is this next section here that's called REST. And in this REST section, we are only interested in the section that says Open API version 3, not any of the other ones, not Flask, not Django, not Git, not any of the others, not REST. So there are many, many pages. So you're only reading Open API section 3 and Open API section via introspection. Now, this is not this week, but the week afterwards. And what we do is we teach you how to use the specification to automatically generate a Python program from a specification that says this is a REST service. And the specification looks somewhat like this. So as you can see, there's zero programming knowledge needed to do at this stage to do any Python. That's well happening at a different point. From these specifications, through a very simple program, which is listed here in this space, and web service is being created. So you can see as this is 10 lines of code, you have created a web service. And so you will understand once we do this, how this is being done. There's an exercise that we typically run through, and then you will be experts in this. This is absolutely no problem. The thing, however, is that we would like to do something a little bit more interesting, because as you know, we are all now looking, or many of us are looking into AI services. And the AI services, you know, something, I give you an example. Scikit-learn k-means. There is this k-means service or API, which has, for example, here a wonderful API with lots of different parameters that are very well documented here in scikit-learn with examples and nice pictures and even further examples. But it has a generalized set of parameters. So now the idea comes into place. Is what would happen if I were to take such a specification and formulate a Python function out of it, and then convert this function to a REST service, but the REST service is actually not a function, but specifies an open API specification that then creates the REST service that we actually have just showcased a little bit earlier, and then automatically generates a REST service that we can place on Azure or Amazon or any arbitrary thing. Naturally, this doesn't have to be k-means. This could be any other function from any other AI service toolkit. And the point is that we have these parameters, and based on these parameters, we should be able to derive a REST service. And in that REST service, this function is being executed and returns a result. This now makes it possible for us not only to develop the code in Python, because we have a generalized specification, but we can automatically, without us knowing anything, creating code in Java, creating code in Go, creating code in Kotlin, creating code in any arbitrary programming language that is supported by tools that take the open API specification and convert them to a particular language. So that's really super cool. This is something that the NIST group is currently looking into intensively, how we can achieve that. So now the good news about this whole thing is, this particular project, is we have actually started doing this already last semester and experimented a little bit. And so we found certain things out. And the particular people that are working on this will at one point have full access to this directory that's called Cloud Mesh Analytics. And in this Cloud Mesh Analytics code, we have a start of doing something this, which is fairly complicated, but I don't want you to look into this at this time. What I want you to look into is there's a test program, and the test program has an example that's called def, example def. When you execute this, you will see that we can actually look into a Python program and, for example, say, okay, the function name of this function that I declare is A. It has two parameters. The first one has a name X and a type integer. The second one has a type Y and integer. And then I'm spitting out a result back out. Here is the Python doc string, and here's maybe the calculation that I have. I just have a returned one over. So the task is now is we define such a function. We derive from this function an open API specification. We then take the open API specification automatically through a 10-line program, which we automatically can generate, basically with a 1-line command. We can generate then a REST service. And then we will be using Cloud Mesh to copy this REST service onto a virtual machine that we stage and run that particular calculation in that REST service. So this is a whole chain of events. And throughout the project, you will learn how we do this. And you will contribute, you will actually do that as part of your project. The first part is most likely the most complicated one. How do we take this Python specification and create an open API specification? Now, the good news about all of this is that I've actually given you the template on how do you get the information here out. Because what I've essentially said is okay, I can, in Python, I just map the function here named A into func. And then I simply print out the attributes that are available for the function. And these are internal Python things. So you would have to look into the Python manual. What does __ name mean? What does __ code co-arguments mean? So you just read the manual page in this, and then you find out that here, for example, returns the number of arguments that are that are present in here. So it would be returning 2. This here would be giving you a list of variable names, X and Y. This would give you the argument count again. See, I should have erased this because this is the first line, and so forth and so forth. And you can just like execute these things and see what actually happens. So you can go in, download this program example dev and execute this. And so you take a Python function, you create an open API, you create a REST service, you place the REST service on clouds, you do a performance comparison. Because we have so many different students interested in this, they need to be addressing all the clouds that we have, like Google, Amazon, Azure, OpenStack, your local computer, whatever other cloud service or provider we actually have in Cloud Mesh. So that's the one project. And if this interests you, I would recommend you sign up for it. And this project will actually be demonstrated in Washington, DC. And you will be mentioned as implementers to NIST. And that's a pretty big honor if you are participating in that. And you need to, however, be delivering, right? So we will set up a special meeting on this particular project and have a weekly meeting. So weekly deliverables are expected. Good. This was fun.
Did you say you wanted this to run on all clouds, or for every single student that volunteers to do this project?
No, see, when you look here at the thing, we have like 5 or 6 interested people in this project. Each one will be doing 2 clouds.
Oh, okay, gotcha. Yeah, that makes sense.
So
do you count Kubernetes as a cloud?
Yeah.
Okay, I was planning on using Kubernetes.
And naturally, this is not necessarily for someone who has just learned Python, right, in the first week. So you should have at least like 2 months experience in Python. Because we are looking actually at the language feature, right? And the language feature is the introspection, right? So by the way, if I do a Python program, what we are doing here is we can declare a class, but there is, for example, let's say I declare a variable a equal 1. We can, for example, say dir on a, and you see all the function, all the methods that are available for a, and that's what we are really doing. We are looking into what a is doing, and then from there we export a specification that creates automatically a REST service. So super cool. So if you decide for this, I would like to start the meetings next week on this project, so that is, or maybe even earlier, so that we can get this off the ground. So let's go back to other projects that we have given an option for. As you know, we have also Cloud Mesh manual in which we have posted some of the projects. So I go here. So let's go here, and there are some development projects here. And the first one was the Cloud Mesh AI service. Here's what I think, and I actually think this is a moderate difficulty. I don't think this is actually, I'm almost thinking it's easy now with this modified thing. Then we have a compute service. This is one of the more simpler projects. We have last semester, a lot of students work on AWS Azure, but we didn't have anybody working on Google. And what this entire titles is, we have introduced you to Cloud Mesh Multipass. And Cloud Mesh Multipass has an abstract base class, and we are implementing the methods in the abstract base class. And so instead of doing multipass, you do Google. That's the best explanation I can bring forward. And so if you want to do that, that's one project. We also have a benchmark project that would be going out and getting accounts on each one of these clouds, and we select then an image that is very similar between each other, and we do benchmark of many of the Cloud Mesh functions. And if you find that something's not working, then we will start fixing that. That's another project that we can do. A student came up with a Cloud Mesh Frugal. There's a Cloud Mesh Frugal. He's selecting the virtual machines based on cost. We could be seeing if we can recreate this project and make sure that this still works and is up to date. It's probably an easier project, but again, this has been done by a student, so you may have to do some additions to this in order to make this viable, such as, for example, this project currently looks only at compute. What is if we were also looking at data? That's one of the other things. Here we have a graphical user interface. Here we would be looking into using an electron-based definition, and we have actually one student already identified that has chosen this as a project. So if you want to join this project, then let me know. This project, however, requires a significant amount of JavaScript knowledge. This project is not for someone that just wants to learn JavaScript. You need to know JavaScript, otherwise you will not be succeeding in this project. So that was this project. Then we have one project still outstanding that we would like to improve. We would like to create a queue of files that we want to copy from one computer to another or from one cloud to another, and then simply execute the copy process of the elements that are in the queue from one cloud to the other cloud. And so that's relatively straightforward project and relatively easy, but it does require you to understand, for example, how a queue works and how to organize that. It will interface with JSON and with MongoDB, which you would be learning all throughout the class. You already know about the Raspberry Pi cluster project, where we take a Raspberry Pi, a number of Raspberry Pis, put them onto a network and create a cloud cluster out of them. Once we have created the cluster, that's the current state that we are currently in, we will be actually putting things such as Kubernetes, Spark, and Hadoop on these clusters, and then hopefully doing some calculations on them. The storage project we already have. We have an advanced project. This I actually find probably very difficult, where we want to do a graphical user interface to a workflow that is being created in the cloud. So where we will probably use an existing workflow generation project, and then maybe moving data or calculations based on our graphical specification to particular multi-cloud environments. These are the standard projects that we have. So these are the straightforward ones. One of the projects that I haven't listed here is volume management for clouds. For example, we are very well off starting virtual machines. We know how to do that, but we don't have code to, for example, put a volume, attaching a volume to that particular virtual machine. And naturally, you would be learning as part of this class how to use volumes and integrate that particular knowledge into a cloud mesh. And similar to our cloud mesh compute abstraction that we are currently developing, and we have showcased you that in the multipass project, we would not only do a compute abstraction, but also a volume abstraction. For example, create me a volume A on cloud X and attach it to the virtual machine Y. And so that will be one of the things that we would like to see happening. We find that particular project the easiest project of all of them, but some people may want to strive, want to be a little bit more ambitious. So then there are certainly projects that you can yourself suggest, but they must not be trivial. So like, for example, I always get this trivial example of sentiment analysis in Twitter. That's completely boring. If you want to do that project, then, which I highly encourage to do, you will have to do, however, 1 million or so Twitter things and not 100. So, and that will be difficult. So that I actually count as a difficult project because you have to do a lot of resources in this particular case. And there may be some special things that we need to be looking into. That I only recommend for someone who has significant programming experience. And you can select, you can choose something else. As I said, one student came up with that Frugal thing, and one student came up with the workflow stuff. So I don't want to hinder your creativity on what you want to do. The one thing that we cannot do is if you use software technology that costs $100,000, that's not a good idea. We want to stick with open source free software that can be used to develop an open source project. I would also highly recommend you to watch the video on Cloud Mesh, which is posted this week. And I highly recommend that you watch this so that you can actually understand how the, for example, storage project and the compute project work, because they're explained there in better detail than I've explained here.
But Professor, this one says that we have to create a cloud on our machine, right? I mean, so compute and storage on your local machine.
Well, you have a file system, right? Yeah.
Right. So, so the compute can be from the multipass, and then we can use the file system for storage. Is that? That's
for example exactly how it works. Okay. Now you will be surprised to see that there's actually a storage, Cloud Mesh -storage module or bundle, if you so want. And if you further look into the storage command, you see, for example, a provider. And here we have an AWS 3 provider. It's already all implemented. But instead of this implementation, which is fairly long, where the students are going out, okay, you know, I want to copy this entire file system recursively from my local computer to the cloud. What they should have done is this: read the file system, put every single file into a queue, and then execute the copy from the queue. And the reason this is the case is because in their recursive thing, the whole thing can only be done in a single thread. But if I put it into a queue, I can use the built-in Python parallel processing routines. With a one-line command, I can execute 3 or 4 of these threads at the same time. So thus, I speed this thing up. So what would happen is you would take the AWS 3 provider and implement this with the queue, and the queue is already in here. So the storage queue that we have designed, and so this just creates a storage queue, and you know, we have a function that's called copy tree. And when you look in how this is being implemented in parallel Python, there's a run method in there that essentially says, okay, you know, map me this thing here into a process pool and execute this in parallel. And I can specify the number of threads that I'm running at the same time. So this is already all in place, but you have to finish this up. And there's even a test there. They can test this out. So there is already a significant amount of code there.
Professor, this is Ashok. There was a chapter on Kubernetes advanced scheduling. Okay.
Yes, you can. That's already given. So if you want to do that as a project, yes, you can do that.
Actually, I don't have much idea what exactly we can do. I know I'm trying to still understand, you know, scheduling options, you know, or trying to set up multi-node clusters and all. But what kind of things we can do as a project on that topic?
So I think my favorite project would be that we create a multi-cloud Kubernetes cluster and try to figure out how we schedule containers across a multi-cloud cluster.
Okay. Okay.
So, like for example,
Sure.
what you have is maybe there's on the one, maybe you can specify on one cluster you have maybe more memory than on the other, right? So the containers that require more memory should be moved to that cluster, while the containers with less memory should be maybe moved to another cluster. That would be one thing. Or let me assume that the cost of the container on the one cloud is $3 versus the cost of the container on the other cloud is $1. Should I not move my cost if it's the same resource and the same time it takes to calculate the result? Should we not move this from one to the other? Can we, for example, calculate the time it takes from a container to be run on different clusters, and then based on the time, find out the fractional cost per minute and choose then basically the one that is minimized? Or I have a deadline, and the deadline needs to be done. On which cluster should I move my container to meet that deadline? These are all very advanced questions. I'm not saying that you can solve all of them,
Yeah.
but I'm saying to you is there's plenty of opportunity there, and the setup of the cluster is not as trivial as I'm setting my Kubernetes cluster up on my local machine and do all the scheduling of of my containers now on my local machine. No, what I'm saying to you is, this is, okay, let's set up a Kubernetes cluster here and there and somewhere else, and then put them together so that they're all registered into the same Kubernetes. And now, how can we make sure that we actually are moving containers to the right cluster? Is it even possible? And this is one of the interesting questions, because we need to be looking into Kubernetes, into the scheduling algorithm, into, is it even possible to start up a Kubernetes cluster across different providers, cloud providers? You know, I don't know the answer to this. If the answer is no, then we do something else, right? As you just heard from me, I have 10 different problems already, right? Yeah. Sometimes we just explore a little bit and figure out where we actually move. That's the reason why we have this phase. You can't necessarily know, hey, what will I be researching in this Kubernetes cluster scheduling? You can probably assume, hey, that's a good project for me because I'm totally passionate about that. And then you put some time in. If you're not passionate about the project, you probably don't put some time in. And that's what this thing is about. And just as in mathematics, right? So I've heard earlier today, someone takes a statistics class. Okay, you know, you can't do any machine learning without knowing something about Bayes, right? So Bayesian statistics, you ought to know, right? You have to do certain things in order to swim in the area where you are actually doing. And the thing that we are doing is virtual machines you need to understand so you can swim there. Storage, volumes, files that we need to be moving from here to there, AI services. That's all different things, just as Bayesian statistics. What you do is you pick a topic and you focus then to become an expert in that particular topic and integrate the engineering aspects that we have in this particular topic. It is not required for you to, for example, know from the beginning on, hey, this is something that I want to, I know every single aspect of this. This cannot happen, right? Because if you would know that, then we would have week number 16, then you have 1 day to do your project. So you will be jumping in the cold water, not knowing exactly what your project is about, but you need to be committing to this because you can't switch projects, because then you run out of time. You have possibly 1 week to switch a project, but I don't think you will have time to finish your project if you want to switch a project. That's the reason why you just jump into this. You find something that you find interesting, and then we go with this. And that's the reason why we have this week here, so that you can start thinking about it, and you should probably start thinking about it every day, and figure out, okay, you know, is this something that you feel comfortable about? In a previous class, sometimes I don't even give any choice. I just assign something. If you don't have any opinion, you give me your background and I assign something.
Okay, Professor. I will review, advanced scheduling with Kubernetes, and then we'll come up with some topic. Possibly you can review once, if it is okay, then we'll proceed.
Yeah, but don't start in the Kubernetes. Don't start too simple, right?
Yeah, right.
There, I would really like to see, just like in other projects. In other projects, we do multi-cloud. Multi-cloud is a topic throughout the entire class. So this is a hot research area for everybody. And naturally, if you go to Amazon, they are not interested in multi-cloud. They're interested that you stay in Amazon. Azure, they are not interested in multi-cloud. They're interested in staying in Azure. So we're doing something that's bigger than a single provider, and that's really the point of this cloud engineering task that we are doing. We are integrating multiple clouds instead of just one.
Professor, what about the Google Open API?
Yeah, as I said, this is a very simple project. This is the same project as Cloud Mesh Multipass, just with Google. Is that enough for help?
Yeah, I will look into it.
Well, you can already see the preliminary installation of this. So if you take a look, I'm not sure if we have already posted this, but there's CloudMesh-Google. There's this Google thing. There's a command. Oh, this is just a storage provider. The compute provider is in CloudMesh Cloud, and we have here under compute and the Google provider under libcloud. And what we want to do is we want to change the Google provider that is here defined by libcloud. We want to define it as with the native Google libraries rather than with libcloud. And here's already a working example for libcloud. But what you would do is you would start just like multipass. You would essentially basically copy the multipass code. You will be doing this in the Google CloudMesh Google code here, and you would be starting to implement these methods one by one.
Professor, I'm interested in the CloudMesh Frugal assignment,
Yes.
but since it's already implemented, what would be the task, like just debugging or
So
adding
the first thing
functionality?
would be is we would be replicating what this particular student has done. And then I would actually argue we look into what would happen so we may have to clean up the code a little bit. But what would happen if we also have a price on data? And so I would think here that you would be having to look into how he has actually done that. And I believe this was just limited to compute. Now the question that becomes also is how do you find out, for example, the cost of volume in Amazon or Azure? And that would be the first question. And then what would you have to do in order to make a decision where you would like to store, for example, your files? Now, as we have all the storage stuff already defined, basically, you can copy files from here to there already, but you would have to make a decision, where do you want to copy things to? So you take that particular information that you get from the websites or from these different providers and make a decision. Okay, do you have a decision of faster access time maybe for the file, or do you have a decision of integrating this cheaply into a virtual machine? So these are two different questions that relates to Frugal that this particular student hasn't even answered. So you would be looking into this project, what has he done, and then try to figure out how we address the next step. And you would be interacting with me on this particular project also.
Awesome, thank you.
So this is an iterative process. So in contrast to other classes, they may actually say, define a project, and then you have 3 weeks time, and then you get feedback. You can get feedback here immediately from me, right? And we also have, for example, one student that works on the satellite disk AI video analysis, for example. That's another project that was being identified. I'm not sure if that student is online.
Yep, I am.
Yeah, so that project is going wonderful because we just got the videos. I'm not sure if I think I posted them online. That means we have enough videos for training and enough videos for actually an evaluation. So one of the things that I would recommend you to do is start doing the write-up, because this is a fairly well-defined project. To, for example, say this is how do you define the satellite disk frames. So you have to draw the frame around. You have to use that tool, that image framing tool that I pointed out, and start developing an algorithm. I wouldn't wait till the very last minute to do these kind of things, because you have to verify that these steps actually do work, right? Then one of the other things that you have to maybe think about is Do you want to go with color images, or do you want to black and white them? Is there maybe a difference between different image manipulation algorithms that you may have to conduct? Those kind of things, for example.